Vinod Kumar, can you unmute your mic? Vinod Kumar, are you there? Anish Paul?
Yeah, hello sir. So I'm still doing.
Okay. So anyone got any voltage sensor?
ZMPT 101B.
Good.
So TMS voltage sensor.
Can you just tell that full component name?
Like it was given like that only TMS voltage sensor and which will be used for measuring more than 50 kilovolt or something in
Okay.
railway.
Okay. But it will be too much costly that if you are getting a full current sensor, which will be directly down converting that so much high voltage. Okay, not issue.
Sir, SK0418,
Okay.
12 volt to 250 volt
Mm-hmm.
after the transfer.
Okay, okay. So now I am sharing my screen. Now we will be interfacing it to our Raspberry Pi. So for that we have to write some few lines of code. Okay. So whatever voltage sensors you are using, first we have to find their libraries. So I will request all of you to just we will be going back and again seeing that video. So here, like we wrote some few lines of code. So you have to import some files and libraries. And once you are ready with this, then you have to use your ADC to just change the modes. Like in our ADC, we're having continuous mode and single short mode. So I want you all to write some few lines of code in your assignment that how you are reading it. Just see, like someone asked that what is that txt file and all. So here I have imported for my this ADC ADS 1015. This code will be same only for you. And here I am writing my this ADC values to a motor reading.txt. And once my this file is ready, I am going back and I am doing data analysis. So here I took this 1 second no load file and have plotted. I got this current waveform, and from this current waveform, I am getting this Fourier transform. So I want you all to come till this position. Means from your voltage sensor, you can directly plot your data and you can plot your Fourier transform.
Where do we write the code?
Come again.
Where do we write the code?
That if you are having any Thorny platform, means if you are having any your Raspberry Pi, you can try your code over there and you can copy and paste that same code on your assignment.
I don't have that.
If you are not having that code, then which board you are having?
Sir, Arduino Uno.
Oh, Arduino it will be. Hmm.
Okay, just pay attention and note down the codes. Later you can do it in a board.
Yeah.
Sunil, you can go ahead. The students can note the codes and they will do it later in a board.
Okay. So only that's it from my side.
Sir, what do we need to submit for the assignment?
In that assignment, you will be having that now that circuit diagram which you have built, how you are interfacing your this ADC to your Raspberry Pi for that code, or any board if you are having how you are interfacing that your ADC to that board, and after that you have to do some data analysis like plotting that signal and to find that FFT. For that FFT, there is a already well, code is there.
So that code we need to write on pen and paper.
Exactly. That is a standard code.
So can you once again clarify, like we have to write the code for what? I mean, on the paper?
See, well, the first thing is that since I think that you don't have that Raspberry Pi code. So whichever board you are having, for that you have to write the code how to interface your ADC to that board, saving a file on it like abc.txt, and you have to do the data analysis on your this Jupyter platform, like taking that txt file, plotting your this signal, and then calculating that FFT or Fourier transform.
So like for getting the FFT, we need to run the code, right?
I think you are having this Jupyter notebook with you.
I mean, I've never used it, but yeah, okay, I know about it. I mean,
Yeah. So you just have to write the code that how you can get it. I'm not asking you to then first like take a file and then you have to run it.
okay.
So we have to write the code for ADC interfacing and the Fourier transform, right?
Yeah.
Sir, since we not have Raspberry Pi board, of what exactly we will find FFT?
Arduino board you're having.
Python runs on
Arduino.
Arduino?
Arduino board you're having.
Yes, sir.
In that Arduino board, there is already a ADC. So if you have to get any signals from voltage sensor to ADC, and to save like some 1 second data in a file called as a.txt, that you can do in your Arduino
But
board.
then we need a signal generator or some voltage measurements at home, right?
Come again?
Then we need some signal generation or some voltage measurement which we don't have at home because we are not supposed to get that.
No, I am asking you just write a code, not to.
Sir, but
do it
exactly,
technically.
yeah, I understand you. But
Huh.
what exact of which signal will obtain the FFT?
I am asking you to just write a code to obtain FFT. Love your voltage signal. I'm not asking you to perform that experiment right now. Are you getting?
Yeah, but you few minutes earlier you said to run in Jupyter Notebook.
Wait, I will just share my screen and I will just write this full thing on a. Then you can understand what I'm asking. I'm asking you, like, see, first you have to make a documentation in which you will be writing that how you are interfacing everything. Okay, once you are done with it, you are having some board. Assume that you are having Arduino board. So Arduino board is already having ADC, and to this you are connecting your voltage. That's this voltage sensor. So I'm asking you to write some lines of code to read this voltage to your Arduino board, and in this you can save it to a file called as a.txt. I'm not asking you to now go and you have to interface this, nothing. Only some codes to save this file. Once this file is ready, you can bring it onto your computer. Assume that you are having a file here called as a.txt. You open your Jupyter notebook. First thing you have to do, you have to plot it. Second thing you have to do, you have to find the FFT. That's it. I'm not asking you to like that. Now only you go and interface this. You will create this file, then take this file and then do plot and FFT. I'm just asking you to write this code and these two codes. This is also already available, and it will use some 3 to 4 lines of code. This is also already available, having 3 to 4 lines of code.
So can you show the how to interface the ADC with the Raspberry Pi?
Come again?
How to interface the ADC with the Raspberry Pi?
Wait, I will show you. So here, I am interfacing that ADS 1015. So for that, I am having my this library. So directly, I'm calling the library, making a instance, modifying the gain and mode, and I am capturing the data. And here I am doing some processing. Like here, I am taking the A0 port gain as 1 and sampling frequency as 3.3 kilohertz. And then I am saving it to a file. So you don't have to go for that later part, just be in that initial part only. And you can see that here my one file it is saved called as motor reading the txt. Once I'm
So can you go down, scroll down a little bit?
Tell me.
Yeah. So what is this? This what which you did
Where?
after handler dot close?
Here I am taking a array. Okay. And in that array, I am saving the datas.
Okay. It's after handler dot close. Yeah.
After handler that close.
Yeah.
All this I am finding that what is the sampling frequency. So this all thing you don't need. Only you have to save it by opening a handler like that file name, and you have to close it. That's it. That I was finding my that what will be my maximum sampling frequency, what I am getting the maximum value, all that you don't have to do. You have to just save that raw value.
Okay.
So what format do we submit the F50 analysis code in?
Come again.
What format do we submit the F50 analysis code in? Like in handwritten or screenshots of the Jupyter notebook?
Handwritten will be good.
Okay.